Welcome to Ford Mod Motor Training Part 29. This video we're going to be taking a look at doing a naturally aspirated Basemap Creation tutorial. So we're going to be working with our VCM editor software, taking a look at our Excel spreadsheet calculator and learning how to transfer some data from the spreadsheet to build our calibration file, and then also going over some general tuning techniques and some tips to tune a naturally aspirated engine in our configuration that we're dealing with here. So a lot of things to cover within our video. Let's jump in so we can check this out and learn how to build a proper base calibration.
Okay, so let's get started. We're going to be taking a look at creating a base calibration file for a naturally aspirated V6 or a 3-valve Mustang application. This is going to be including all the things that we've learned within the training course and rolling them into this video. It's going to be a guide for creating a base map. You might find some of your modifications might be different than what I'm going to be hypothetically covering and going over in this video, but we'll find the process and order of operations for creating the file and then doing the general tuning and workflow process we're going to cover here will be applicable to your situation. So let's jump in right now and open up a calibration file. We'll go here to File, Open, and then I'm going to move into a stock 2005 Mustang GT 4.6 liter file. Now I'm going to assume that you're starting off with a stock calibration file, so you don't have something that's been modified already from someone at a previous point in time. Now if you do have that situation, you want to go and use the repository feature or use one of my calibration files that I provided and make sure you changed all of your values back to stock values to create your base file from. We don't want to inherit any bad data or any tables that might be set up incorrectly when you're starting off in your tuning process. If someone already has tuned the car, we want to essentially put a reset button on the calibration file. So we want to again return the back to stock using the compare feature, copy and paste between your stock equivalent file and your file that you're working with, and then save it as a new file name. And then that's what we're going to be starting off with looking at in this video. So I'm going to be assuming in a naturally aspirated setup that you're going to have typical bolt-ons, long tube headers, exhaust, cold air intake. Now you may also have a set of injectors installed. You might have also went in and changed out the throttle body and intake manifold, and then in more of an extreme situation, you might have a built engine with larger than stock camshafts. So we're going to take a look at a couple different things within this video, but for sure we're going to be covering how to deal with long tube headers and then how to deal with our injector data programming and making sure that we have our mass airflow curve represented properly. So first thing I want to do here is actually jump into engine. Now under engine, we're going to have all of our different sections to talk about. I'm going to start off here under general, and we're going to work our way across here from left to right in our screen. And then we're going to also go across here from engine all the way down here to speedo and go through all of our sections here. Again, this is just focusing on creating the base file, the key points, the key things that we need to go and make sure we update and change to make sure the engine fires up and runs and we have the best success in starting off our calibration process. So within our engine here under general, the only thing that we have to consider is going to be our engine displacement. We might need to update. If you've changed the bore or stroke on the engine, if you've pulled the engine apart, rebuilt it, and you're changing those components out to make a larger displacement engine, you'd have to represent that here in the engine displacement. The units here are going to be in pound, not in liters or in cubic inches or cubic centimeters. We're going to make sure that we use our calculator that are provided within our Excel spreadsheet from our course packet. That's going to represent right down here in the calculator the bore and the stroke of the engine. That'll give you the engine displacement in our parameter here that you can use to copy and paste back into your file. If you don't or you have not changed the bore and stroke on your engine, if it's still a stock engine, you don't have any reason to change that value from your file. That is going to be one of the most important things that we update right off the bat, because this is an overall fuel multiplier, the way this is going to work against idle part throttle and wide open throttle. And essentially, if we don't compensate and account for the engine displacement, if we actually changed our engine displacement, we'll find that everything is going to be off on our airflow modeling or the fuel modeling. So we need to make sure that that's right. That's one of the fundamentals. So right off the bat, in this case, I'm not going to change it because it's a 4.6 liter. That's the file I'm working with. I'm assuming I'm still a stock engine, still stock bottom end. Under idle here, we have a lot of different parameters that we could update and change. The only thing we really need to focus on right now is going into RPM and deciding if we want to go and change our park neutral and drive RPM. Now, if we have stock camshafts, there's no reason to really change this from the stock values. If you have larger than stock camshafts, you may want to go and bump this up another 100 to 150 RPM. If you have, again, larger than stock, that's going to be losing a lot of engine torque. By bumping up our engine speed a little bit, we'll be able to stabilize the engine idle RPM a bit better, because we'll gain back some of the lost torque that we would find when we installed that larger than stock set of camshafts. So it's going to be really up to you what you want to do. In this case, I'm going to keep these stock values because I'm going to assume that I have stock camshafts. Now under airflow, we're going to have a lot of things to discuss. Under general here, we find right below here we have map sensors set to disable. We don't have a map sensor on our 3-valve applications. We're going to assume it's disabled. Under the barrel pressure learning, the minimum, we want to set this to 27. This is going to be limiting the range that the barrel pressure can actually learn within. I don't know if I mentioned this within the main training course videos, but that's something that we definitely want to do. That's going to make sure that it doesn't go and it can alter the barrel correction side of things too much. Now under the MAF calibration, we have our airflow versus voltage table. This is probably one of the most fundamental and important tables to program and to get right within the PCM as we're doing any of our tuning. Now if we've installed a aftermarket intake, let's assume we're installing a cold air intake, we need to go and update this because we're going to find that at a particular MAF voltage, if we have a larger diameter than stock intake, we're going to find a different airflow amount coming into the engine through that particular MAF housing size change. We need to represent that in the table here so that we accurately determine what the airflow is being ingested into the engine. If we don't, we're going to find we misrepresent the airflow, and therefore we're going to have a fuel modeling and airflow modeling problem that's going to lead to all kinds of issues. So we need to make sure that this table is dialed in right. Now if we go into our spreadsheet here, in our very first page under MAF, we're going to be finding that we have a way that we can take the stock MAF diameter, and if we've put a larger than stock MAF housing size, or we've changed our intake from the stock size to a larger size, we can represent that here. So that's our new MAF size. So this is our stock, this is our new. These are the inner diameter measurements from the actual intakes we're working with. So we need to make sure that is important to note. You're going to use a ruler or a tape measure and measure the actual inner diameter. So in this case, we're assuming stock would be 3, and the new one we're installing would be 3.5. Now, in order to make sure we've updated this calibration curve here properly, we would take our airflow right here, so we'd copy this, we would jump in here and we would paste it into the stock column right here. Now, by doing this, and by putting our parameters here into our calculator, we're going to find that rescales our MAF size right here. So in the blue, this is what it's correcting. Again, if we're using a stock MAF sensor into a intake that we've created, this might not be an aftermarket intake, might be something we've actually fabricated. So 3 to 3.5 inch, this would be the difference at a given voltage of what the airflow that needs to be updated. So the MAF curve is calibrated properly, and we have a good point of reference for starting, so we can see we copy and paste. So if we're not going in and installing an intake that's going to be a slightly different diameter, let's say we're installing an aftermarket intake that's a known brand. Our second page of our data sheet here, we're not going to be using that rescale calculator. We can actually use what I've provided here for voltage versus airflow curves for popular intakes. We can see their label up at the top here. So what I'm going to do is, assuming that I'm having, let's say, the C&L 95mm race intake that I have to install, we need to make sure that we're noting on the axes here, so the voltage axes, we're going to find that that may be different than the stock values. So we need to go and update that. So what I'm going to do here is grab the value here, grab my voltage curve, and then I'm going to go in here and I'm going to right click and go into my row axes and go into edit, and then make sure I paste that because that could be different. In this case, that was the same. It wasn't any different, but I made sure that that was copying and pasting that in there. So it may be different on your calibration file depending on what you're dealing with, and we want to go and copy our voltage axes into the file we're working with. Now the next step here is to go into the actual flow amounts from our curve and then copy that into the actual file here under airflow. So copy paste. So now we can see we've copied that data right from our Excel spreadsheet right in here. That's going to be a great starting point to get us going with that particular intake, or again using the rescale that we've talked about here in our previous video. Now there's going to be some additional things we need to do in our MAF calibration area here so that we're not going in and having any influence from our speed density as we start to calibrate and get our engine up and running. Now the first thing we want to do here under MAF adaption here is set to the disable. This is going to be disabling any kind of learned adaption that's in the background in the keep alive memory of our PCM. So that's going to be making sure that it doesn't influence and alter what we're dealing with from our raw MAF curve. The next thing we need to do is jump into our default barrel and raise this to a value of 30. That's going to make sure that this doesn't skew out or alter any of our speed density calculations once we turn back all of our adaptions, filter, and anticipation back on again. Now under cylinder air filter, we want to go turn this to disable so it doesn't filter out anything from our mass airflow, so it's providing the raw signal. And the cylinder air anticipation is going to be also set to disable, so it's not using any kind of load registration or any kind of kickback into the speed density calculations. It's focused just on the mass airflow curve. Very, very important, so we get that dialed in right when we begin our process. And then once we dial it in, once we dial our failed MAF tables in, then we can turn back all of these checkboxes to enable, and then we can start to review.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.